With the implementation of this project, we can witness marvels of engineering features applied to overcome challenges faced by the project team. One of it is to materialize the compact 7.3 hectares land to be able to accommodate sewage inflow of 920,000 PE, which is almost 3 times larger by the current practice of Malaysia's sewerage industry guidelines. Today marked another record in Malaysia engineering achievement by Malaysia Book of Records, enlistment for the longest micro-tunneling diameter 1,800 mm curvature breakthrough for 725 meter pipe length. More of these innovative technologies should be adopted and applied in the future for benefit of the people and environment. Remember, modern sewerage is no longer a pipe dream.
Safety of Retail Procedure dan safety measures yang ada di site kita pada hari ini. Seperti yang terdapat dekat sini merupakan Safety and Health Notice Board.
Our longest drive in this project from K0123B to K0127. So, this is actually the longest project will be recorded in the Malaysia Book of Records.
We are now at the AVN Harun-Kanish control cabin. As said that this is a 1800 machine. So behind here is actually the control panel itself for the operator to operate. It's all automatic, remote, whereby the operator doesn't need to actually go inside the machine itself. And behind me here is actually the setup plant, the separation, the STP, the slurry treatment plant for this drive, which is the 740 meters long special drive. It's a rock which is basically with high quartz, and then the harness is between 80 to 100 MPa.
Good afternoon, everyone. So it's now 3 o'clock. Welcome back to the Malaysian Water Association and the Malaysia International Water Convention webinar series. And today is our 10th webinar in this series. Today, we are pleased to have with us retired Major Zulkarnain bin Yaakob, Deputy Project Director, Langat Sewerage Project from MMC. Major Zulkarnain will be sharing with us on the challenges, benefits, and achievement of the project. And today, joining Major Zulkarnain will be 2 more members on the panel who will help him in the Q&A session later on. And they are Engineer Zulkifli bin Abdul Hamid, Director of SMHB Engineering Sendirian Berhad, and Engineer Din Muhammad Kafar Khalid, Associate Director and Senior Resident Engineer from IRICO Sendirian Berhad. So we invite all attendees to participate in our survey which we will show midway through the session. The purpose of our survey is to collect feedback from the industry and public. So where necessary, this data can be used by the Malaysian Water Association to prepare reports and make representation to the government or regulators on the subject. So please support. And for those of you who have questions for our speaker, the Q&A icon, I hope you can see it. The Q&A icon is at the bottom of your screen. So just click on the icon and you can key in your question anytime during the presentation. So I hope that's clear. And now, without delay, I'm going to invite Dato Engineer Abdul Kadir bin Muhammadin, President of the Malaysian Water Association, to say a few words before we start. Dato
Okay,
Kadir,
thank you. Yeah, thank you, Dennis. Welcome again.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Ladies and gentlemen, good afternoon and welcome to today's MWA organized webinar series again. And this afternoon is our 10th in the series. And today the webinar presentation will look at something interesting on engineering aspects with regards to the Langat Sewerage Project, challenges and achievements. This is another mega project done by our government. And it will be, as been said, jointly presented by MMC, Pembetungan Langat Sdn Bhd, SHB Engineering Consultant, and Arinco Sdn Bhd. As we are aware, infrastructure has significantly, but often unseen, impact on the ability to implement economic development strategies. And for commercial centers in smaller towns, the ability to expand business may be affected if there is no proper sewage system. Individual septic tanks used to be used. I mean, back in 1970s and 80s, this is quite widely used. And therefore, it occupies some space, small space, but nevertheless, it's considered haphazard. And under current policy, anything more than 30 units, you need to build a treatment plant. Thereby, when talk about treatment plant, the small treatment plants has mushrooming since 1980s and till today. We still have a lot of small treatment plants. And these occupy lots that may be restricted in size of the business. And based on the required size of each field is associated with a traditional septic tank compared with. The placement of the septic tank or small in-house tank and the like of the treatment plant that we have on the lot may also affect as the restriction of preservation or development of walkable town center. If the system is in front of the building and public amenities will be pushed back from the street, reducing the impact of the activity generated by the business on the street life in the area. In Malaysia, extensive use has been made of primary treatment system, such as the communal septic tank and in-house tanks, and unreliable low-cost secondary systems such as oscillation ponds. But that has been phased out. And in addition, many urban areas still utilize individual septic tank currently, and it's estimated that there are over more than 1 million individual septic tanks and more than 3,000 communal septic tanks in Malaysia, and that is registered. I'm guessing that the figures will be more than what I have stated just now. These tanks only partially treat sewage, discharging and effluent still rich in organic material. This has a potential creating the public health and environmental problems, particularly in urban areas. The government has a program to rationalize the public sewage facilities to reduce the number of small treatment plants using the multi-point concept, or in more common term, regionalization. Sewerage pipes networks will be then laid in urban areas currently serviced by the individual septic tank to convey the domestic sewage to modern secondary treatment facilities. These extensive programs are nothing short of a revolution in the management of domestic sewage in Malaysia. The entire sewerage infrastructure can expect to undergo changes. Our National Water Association is pleased to organize this webinar on the technical aspect of the Langat Centralized Sewage Treatment Plant today to let the audience have a better understanding on an example of the concept of the regional or centralized sewage plant and how it contributes to the social and economic development of the area. Ladies and gentlemen, the Langat Sewage Project is one of the sewage non-river projects under the Greater Kuala Lumpur, anchored under the Ministry of Environment and Water and implemented by the Jabatan Pembetungan. The high impact project involved building a centralized sewage treatment plant with 920,000 population equivalent. That is equivalent to about roughly 207,000 meter cube a day of treated sewage, and laying sewage piping network of approximately about 108 kilometers in total. The aim of this centralized sewage project is to rationalize and improve the sewage treatment services in a modern, environmentally friendly way. The more than 108 kilometers of sewage extension was implemented to reduce the number of existing inefficient sewage, small sewage treatment plant around Cheras, Batu 11, Baiduri Village, Cheras Jaya, Kajang 1 and Kajang 3. The new centralized sewage treatment plant integrates 164 small inefficient sewage treatment plant and links them directly into one centralized location. And this is the aspect of reducing the more than the 7,000 plant currently managed by Indah Water Consortium. The goal of the new plant is to improve the quality of treated wastewater and reduce the sources of pollution and help to preservation of Langat River's water quality and reduce the burden of contamination on the nearby water supply treatment plant. The completed projects involve the decommissioning of all these 164 old small treatment plants. This is important in order to prevent pollution of rivers due to the existence of the old septic tank. If the quality of water supply is not protected, we risk contamination of future drinking water. Sewerage pipes to connect the homes to the plant will be constructed once the sewage treatment plant is completed, I guess about in a year later. Thereafter, we will see toilets will become cleaner and smell better. Wastewater will be flushed straight down the pipes to the plant, and at the same time, residents will also enjoy cleaner exterior home environments due to water from kitchens and bathrooms not flowing into the outside drain. And this is what we term as silage. This silage is another culprit to the environment because it pollutes the rivers. So the risk of flash floods will also be reduced as no leftovers like fish bone and plastic would accumulate in the drains. The more than, about 1.5 billion cost of the plant will be able to treat raw sewage from category 1 standard A effluent as stipulated in the Environmental Quality Regulation 209 before releasing it into the Sungai Langat. Thus will improve the condition or the quality of Sungai Langat as a whole. Ladies and gentlemen, the massive Langat Centralized Sewage Treatment Plant in Selangor has set a new benchmark for the nation's sewerage industry in various aspects. One of the highest recognitions is where the project recorded the longest micro-tunneling with a diameter of 1,800 curvature sewerage pipeline in Malaysia and in the Malaysia Book of Records in May 2009. So instead of construction of 4 shafts, only 2 shafts constructed with the length of 725 meters with 90 meter depth. The plant's odor reduction features also made possible with Japanese technology, reducing the ammonia output by half. And the plant system is enclosed, unlike the conventional open pond system, and the built-in green technology features to generate biogas and harness solar energy as supplementary power for operational equipment. So as you can see, the modern features of treatment plant is not built to waste, but built to recycle. And that is in line with the waste to energy and waste to us. The development also houses a sports center featuring futsal and badminton courts and children's playground and community hall for the public. And I would say this is another state of the art of the design that has been built compared to the Pantai 2 treatment plant that was completed a few years ago. Nevertheless, as Malaysia population, urbanization, and economic activities rapidly increase, the pressure on the freshwater resources increases. Steady increase in living standards, economic development, and pipe water supply means an increase in water consumptions. This led to increasing volumes of wastewater, and if untreated, leads to increasing volumes of pollution. Pollution load into the environment has caused and continues to cause gradual but steady deterioration of water resources, and hence the ability to provide safe drinking water to the population decreases. As a result, the basis of economic activities become threatened, the Langat STP project is a timely and much needed project crucial for the sustainable water resources management for urban areas like the Klang Valley. Similar to water supply, sewerage is not an option anymore, but it's a must utility for any development, be it in urban or rural areas. Finally, a big thank to the prominent presenters today, Major Zulkifli bin Yaakob, our engineer Zulkifli Abdul Hamid and engineer Muhammad Fauzi Sulaiman, who is making history for our Malaysian sewerage industry and who has come forward to share some of the very valuable information on the development from day one of the Langat STP project, and also to our webinar host, ProTem Group, who has been hosting this continuously. And for the next few months, we will have similar seminar of different topics. I wish all of us a successful and fruitful webinar, and thank you. Dennis, all to you.
Thank you, Dato'. Thank you, Dato' Kadi. So now, without further ado, I would like to invite Major Zulkarnain bin Yaakob, Deputy Project Director, Langat Sewerage Project, MMC, to start his presentation. Major Zul, you need to unmute yourself, Major. I think you are still muted now. I mean, yeah, you need to unmute. Okay, there you are.
Yeah, thank you, Dennis. Assalamualaikum, salam sejahtera. Good afternoon, everyone. Okay, I would like to share some knowledge about our achievements and challenges in implementing this project. And then together with me is the other two consultants which involved in this project from day one, IR Zulkifli Abdul Hamid and also IR Din Khafa. Okay, this project is implemented by the Government of Malaysia under the Ministry of Environment and Water. The implementation agency is Sewerage Services Department, or known as Jabatan Perkhidmatan Pembetungan. They have appointed project management consultant, Gabungan AJP and MFA, led by IR Haji Zulaimli Syari. And we, MMC Pembetungan Langat Senyam Berhad, as the main contractor for design and build, led by Cik Muhammad Abdul Fattah as project director. We have appointed Erinco as the storage conveyance system consultant, SMHB Senyam Berhad as our CSTP design consultant. At the same time, we appoint Cunningham Lindsay and Jasa Sendi to conduct the DLAP survey before we start the works, especially along the sewage piping network. And then we will also appoint Tokyo Metropolitan Government to assist us on the Tokyo technology for this project. Okay, this project started with a site possession on 20th November 2015, with target completion date 28th February 2023. The contract period is 76 months, followed by the defect liability period 24 months. A little bit project overview. This Langat project is one of the sewerage non-river project under Greater KL. The main objective is to rationalize 164 existing small and efficient sewage treatment plants and pumping stations to a centralized sewage treatment plants in order to improve the quality of treated wastewater and to reduce the sources of pollution into Langat River. So the project of the sewage non-river, there are about 13 numbers. Initially, there are 3 plants under the catchment of Langat: Cheras Batu 11, Cheras Jaya, Kajang 1, and Kajang 3 STP. And we consolidate these 3 plants into one single plant. We call it Langat Sewerage. Treatment Plant. This is Langat River Basin. We are located at the yellow color. Our catchment is about 77 square kilometer. Along this Langat River, there's a lot of water intake plants. So these water intake plants serve most of the water supply to Wilayah Persekutuan, Kuala Lumpur. And then we are located down south. The catchment in Langat for our project is about 77 square kilometer. And downstream, we have, after our discharge point, about 25 kilometer, we have another plant, Bukit Tampoi. This is the source of pollution to Langat River, and 31% contributed by STP. This is a pie chart. 31% of the discharge that polluted the river is coming from STP, and 7% from private STP. Okay, this due to the contaminated discharge or inefficient plant. It causes a lot of ammonia content discharged into the river. Sometimes the water intake plant need to shut down. So most of the plants within the catchment are unable to treat ammonia, more than 80%. So it's very timely to have the new plants which can treat ammonia. Okay, this is the histogram showing the number of plants within the catchment. Mostly are located in MPKJ area. There are 249 numbers public and then 25 numbers private plants. So this MPKJ area covers about 1 million PE. So this is the terrain model within the catchment. The Langat River flow from the north to the south. So most of the catchment area is also situated on the hilly area. So we had tried to design as best as possible to use a gravity flow. So most of out of 108 kilometers, 90% of the network by gravity flow, only 10% by force main. This is a catchment. The white in color is our scope of responsibility under our contract. The magenta color covered by different contractor, but the flow coming to the same STP. These are our stakeholders. Mostly are the local authorities and utilities providers, and also the public, which is the ADON, Ketua Masyarakat, NGOs, penghulu, and also the committee, the residential committee. The purpose of the project is, number one, is to rationalize and improve sewage treatment services in the basin of Cheras, Kajang, Selangor, catchment area 60.9 square kilometer, which is our scope. To rationalize 164 numbers existing plants within the catchment, so is part of the scope. And lastly is to reduce the water pollution by closing down all the plants within the catchment. The project objective given to us, number one, is to comply to Category 1 for the Environmental Quality Act 1974 for the effluent discharge to Langat River, to reduce sewage pollution, ammonia especially, to Langat River, and to consolidate multi-point STPs within the catchment. And finally is to minimize the operation and maintenance costs by closing down the multi-point STPs. So this is the layout of the plant. You can see how compact the plant is, where all the spaces available within the land plot is being utilized. This is one of the challenges for us. This is the perspective view of the plant within the 7.3 hectares or 19 acres land. The constraint that we are facing, the site is extremely tight with irregular shape. And then we need to make sure that the process unit tanks is fully covered with maintenance floor and recreation facilities above the plant. And then we have to, the pollution in Sungai Langat is high, especially ammonia, because of most of the small plants not designed to provide ammonia removal. And then lastly, the effluent quality criteria requires advanced treatment for total nitrogen ammonia removal process to improve Sungai Langat River water quality. Okay, this is the shape of the land given to us. So the size of the land provided is suitable for 300,000 PE plant, but with the technology and Tokyo know-how, we can fit into 920,000 PE within the 7.3 hectares. This is a cross-section of the plant. On top of the plant, we have spot facilities. And then in the middle, we have a maintenance floor where a vehicle can drive to this maintenance floor in the future in case we need to replace the pumps and the motors. And then you can see the plant is semi-sunken. The depth is 10 meters, 5 meters is underground. And we have a double decker at the primary tank and also the secondary tank. This is another view of the cross-section. This is the design criteria. The absolute value is the MSIG design parameters, but we design lower than MSIG parameters to ensure that we comply to standard A, category 1. So at present, based on our operation, we managed to remove BOD 96%, suspended solid 93%, COD 88%, ammonia 83%, total nitrogen 80%, oil and grease 96%. CSTP process, we have screening and cost and fine and for grid removal, grease removal, balancing tank and primary clarification, advanced activated sludge using step fit 2-stage denitrification with deep aeration and secondary clarification, effluent compliance to standard A category 1. And then we have a primary sludge from the primary tank, go to the gravity thickener, secondary sludge, go to the sludge treatment building, and then we treat the sludge, discharge to the anaerobic digestion to produce methane gas to be used to generate electricity. And after that, we discharge the sludge with minimum dry solid 20% content and cut away to the landfill. We also provide the auto control for the incoming sewage at the pump station and the sludge treatment building. For this auto control, we use a biological filter and activated carbon. This is a process flow of the sewage incoming to the plant through a grid chamber, distribute to the primary tank. Any overflow will go to the balancing tank, go to the reactor, and then to secondary clarifier, go to the disinfection tank and discharge to the river, to the outfall. The location of the outfall is about 300 meters from the discharge point, from the plant. This is solid line process, the sludge treatment. We have primary sludge and secondary sludge. So primary sludge is from the primary tank, go to the gravity thickener. The secondary sludge from the secondary clarifier, go to mechanical thickener, process, thicken, and then go to the digester. Then the digested sludge will be go to the dewatering unit, and then to the sludge silo, and then cut away from the site to the landfill. This is a step-feed two-stage denitrification process introduced for this project by the Japanese. So we have influent coming to the NOC tank, then we introduce a blower to the aerobic tank to remove the nitrogen, then NOC tank and also aerobic tank before we go to the secondary clarifier. The wastewater treatment proposed for the Langat is an advanced activated sludge process utilizing the step-feed multi-stage denitrification process with deep aeration. The modification of the basic activated sludge process reconfigure of the aeration tank to be used to achieve low levels of ammonia and nitrate nitrogen in the effluent through nitrification and denitrification process. Reactor tank is compartmentalized into repeated anostic and aerobic zones to provide efficient nitrification and denitrification. After primary clarification, sewage is fed simultaneously into both anostic zones. In the aeration tanks, air is fed through diffusers located at mid-depth of the tank. So the diffuser is in the middle. Normally under the conventional plant will be at the bottom of the tank, but to reduce the energy consumed, the technology put the diffuser in the middle, and then with the study, the research that they have conducted, they make the water circulating inside the tank. So they can have a deeper tank than the conventional tank. So with the Japanese also, we do the land constraint. They also make use of the rooftop for other purpose. So we emulate that concept to this project to have the sport facilities and the communal facilities on top of the plant with a separate entrance to maintain the security of the plant. So by having the deep aeration, we can have a smaller footprint for the tank. So the land available, 7 tractor is meant for 300,000 PE STP, not sufficient. But with the technology brought by the Japanese, we are able to squeeze the 120,000 PE within the site by using the deep aeration tank method as proposed. So the deep aeration tank reduced the footprint by 50%. This is the illustration showing the conventional on the left side with 5 meter depth, and then with the deep aeration, 10 meter depth, where we introduce a diffuser plate in the middle for the process to take place. So this is the research they have done. The water can spiral within the tank to remove the nitrogen and the ammonia. This installation on site, the diffuser and also the baffle plate in the middle. This is the tank that they have in Tokyo to show how the movement of water within the tank. This is the study they have done. So for the blower, we have 7 units, 7 numbers, 2 small and 5 same size, 5 bigs. So this is one of the introduction by the Japanese. Normally, we have under MSIG we have standard size, same size, but in view of the operation, we don't need to start all with the same size. We can start with a small size because as the flow increase, then we can have a bigger pump to process or to be activated. This is the layout of the tank, the reactor tank, anostic, aerobic, anostic, aerobic. So we have the inflow to remove the hydrogen and also the aerobic tank to remove the nitrate. This is another picture that shows the process flow, where the incoming from the primary clarifier go to the reactor tank, NOC, aerobic, NOC, aerobic, to remove the ammonia. So this is a more detailed kinetics of the water flow within the tank. So the design variation that we have adopted in this project, the tank is smaller compared to if we adopt the design parameter by MSIG. Basis is that sufficient BOD is moved over into the NOC tank compartments of the reactor tank to act as carbon source for efficient denitrification. The size to provide sufficient aerobic solid retention time for nitrification, minimum 5 days, and the hydraulic retention time for denitrification, minimum 3.5 hours. Sizing is based on Japanese design standard criteria published by Japanese Sewerage Works Association, which is differ from the MSIG. So we have conducted a few workshops together with SPAN, JPP, and IWK to answer all this research that what the Japanese has done in the plants in Tokyo. The secondary clarifier also smaller compared to the design according to MSIG. Design is in accordance to practice in Japan. The main difference outlined below, the fine screens and grid removal before inlet pumps is a practice in Japan. The opening size of coarse and fine screens also different. We use in Japan we use a 120. This the fine screen compared to Malaysian standard. The grease removal at the pre-treatment inlet to primary clarifiers. Capacity of balancing tank is 1.5 hours multiplied by Q peak minus Q average. So whatever overflow will go to the balancing tank. The continuous operation of sludge treatment will be 24/7 instead of 8 hours for 5 days a week as per MSIG requirements. This is the illustration. The grid chamber after main pump is according to MSIG. The primary screen MSIG 25, followed by the next one after pump is 12. But the Japanese introduced coarse screen and fine screen back to back, 120 before the pump. This the main reason is to protect the pump from damage. So the detention time for grid chamber according to the Japanese standard is 1.3 minutes. The Malaysian standard is 3 minutes. So the less or the shorter detention time just in a smaller tank compared to the MSIG. This is another illustration where the automatic coarse screen will remove all the debris coming to the plant. And then only the small passing through to the grid chamber before the pump to protect the pump from damage. This is another screening removal process where you take out the debris from the plant to the screening hopper. And also another one is to remove the grid through the grid hopper. This is the picture of the grid collector where you have a grid pump.
Hey, Major, maybe
Yes.
we should stop here just for a second, well, 1-2 minutes, while we
Okay.
pull up the whole question for all our attendees. You can have a sip of your coffee.
Okay.
Attendees, so today we have 4 questions. So read the questions and answer them. You can scroll down the questions. Okay, Henny, you can show the results. Question 1, 92% agree. Attendees, you can scroll down the results so you can see all the 4 results of the 4 questions. Okay, is there anything else you want to share, Henry? Okay. Just a second, Major. So today we'll be sharing 2 advertisements from our advertiser. The first one is Outnet. And the second advertiser is from Premier Water Services. Thank you, everyone. So we'll now continue with part 2 of the presentation. Rachel.
Okay. So the balancing tank sizing is 1.5 hours divided multiplied by cubic minus Q average.
Major, your slides are not up. Can you share screen?
Share screen. Share screen, share, okay. Okay, is it okay?
No, we can't see. There is a green icon at the bottom of your screen. A green color share screen icon at the bottom of your screen. Can you see?
Yes.
Okay, we can see now. Thank you.
All right. So let's continue. So this plant is also have a green technology initiatives. Number 1 is to convert the gas collected from the digester and convert it to electrical. We have, if the at full capacity can generate 1.2 megawatt power. Next is we use the effluent water to clean up the tank. The reused water is about 2,500 meter cube per day. We also generate solar for the small power for the plant use, 200 kilowatt. And also we harvest rainwater, 10 meter cube for the cleaning of the toilets, for toilet flushing. So the benefits of the project now is number one is to upgrade the sewage piping network that will cater for higher number of people, for higher connectivity, 120,000 PE, to improve the quality of life, the surrounding community by providing access to a modern high quality sewerage services, whereby all the old plants will be closed, there are no more unsightly views and odor, improve the quality of raw water from the Sungai Langat, where it can be used for water intake plant, clean river to promote recreational facilities, recreational activities along Langat River. The project also bring aspect of green technology, which will raise public concern about environmental issues and also to accelerate the process of water integration and rationalize sewerage industry, which will open the ideal integration path and water cycle. So the catchment from the Cheras Baiduri, Cheras Jaya, Batu 11, Kajang 1 and 3 will divert to the CSTP plant, and then another 250,000 PE will come from Kajang 1 and Kajang 3, which is under different contract. So this is the location of the CSTP next to the Grand Saga Highway, the red in color, 7.3 hectares, and then the river is just 300 meters from the plant, and then the most left is the highway. So we move to the storage conveyance system. So this catchment 66 square kilometer or 60.9 square kilometer under our scope, we divided into 7 zones. Actually, network is more challenging to implement compared to CSTP. So the pipe varies from 225 to 2.1 meter diameters. So as you can see, the blue color is the work balance. It's about 12 kilometers. The green color is the one that we have completed. So within the network, we have 11 pumping stations, 8 new and 3 upgrade. The depth of the pipe depends on the ground. As you can see earlier in the slides, we have a higher ground, quite hilly, on the north and on the west side. So we follow the road reserve. So when the climbing uphill, so to balance out the gravity flow, we have a deeper manhole and deeper pipe. So the manhole distance between the manhole distance is varies according to pipe size. The smaller pipe is 80 to 100. And then for bigger pipe, the distance length is longer. For 50 to 600, 120, 750 to 900, 250 meters, and more than 750 mm diameter pipe, 300 meters. And then 90% of the pipe installation by pipe jacking. This is the construction method. So at every location, at any time, we need to have 3 pits simultaneously, so that we don't have a lull time or delay during the construction. So the method is by pipe jacking using a macro tunneling machine or tunnel boring machine. This is the process. The first is we construct the shaft. Then if the machine is not ready, we close the shaft and open the road to traffic if the shaft located on the road. But if the shaft located on the roadside, on the road reserve, don't disturb the traffic flow, then we just put a proper hoarding and proper signage. when the machine available, we lower down the machine, we lower down the pipe piece by piece and jack one by one from one location to another location. Okay, this is the video. The challenges about this piping installation is we have to make use whatever space available on the road reserve. So if no space available on the road reserve, then we have to close one lane to allow for the logistic for the pipe materials, the slurry tanks, the genset, and then also the place that we have to bring in all the equipment. There's a short video that show how it's constructed.
Trenchless installation, for which a hydraulic machine pushes the borehead from a starting to a receiving pit, minimizes costs and impacts on the environment and population.
So for a bigger pipe, we use a sheet pile. So the depth average is about 8 to 14 meters. And to cater for the jacking works, we have a truss block to absorb the force, the hydraulic force. We install the rail, followed by the cutter head and the 3 segment of the equipment, the motor, and also the pumps. Then we jack the pipe piece by piece from one end to the other until we reach the other end. We will extract, lift the cutter head and leave the pipe inside. Okay, this picture is somewhere overseas, but after we complete the jacking work, we extract out the sheet pile and then install the manhole and do the reinstatement works, open back the road to traffic. So this process of jacking works depends on the ground condition. If rock, then the jacking rate is about 0.5 or 200 mm per day. But if no issue on the rock, then we can achieve what 6 to 8 meters per day. Then after we complete the jacking works, we construct the manhole and do the reinstatement works and then open back the road to traffic. This is the balance of work that currently we have on the project. So we have balance of work for the jacking work 11.8 kilometer. Out of we have completed 83.8 kilometer. Okay, this is the overall shaft works by zone that we have completed. So the northern zone, the blue in color, is ongoing. The balance about 70 numbers. Similar to the jacking works, as mentioned, about 11.8 kilometer balance. So most of these manholes are located within the taman. So there's another challenge for us when we construct the manhole for the jacking, the shaft for the jacking works. We have to find a suitable place to put our logistic, our slurry tank, our genset, our pipe, so that it won't disturb the traffic. So within the catchment is about more than 250 taman, and most of the existing plant is located within the taman. So somehow the pipe route have to go through the taman for us to divert the flow from the existing STP to the centralized STP. So as you can read the remaining numbers of the work that for every zone that we have currently. So this, in order to make sure that the site is safe for the public and also for us, we have hired a traffic consultant, TND, Sdn Bhd, to do the traffic management plan and submit to authority for approval before we come in and construct the shaft and also continue with the jacking work. This is a sample of traffic management plan that we have done on site. So some of the site is, if we have space, then we construct on the roadside. If don't have space, then we have to construct on the road itself. And if the machine not ready, we close the shaft and then open for the traffic until the machine is ready to come in. Then we open back the shaft and continue with the jacking works. So overall, for the challenges that we are facing during the construction is on the weather, the geological condition. If you have granite, we have a problem. Our productivity is very low, slow down our works. And then the weather also giving us difficulties, a challenge. So every day we need to pump the water out from the shaft before we can start works. It might take 1 hour or 2 hours during if the night before is a rainy day. And also during the construction of the shaft, we need to make sure that the water tight, so that the water don't come in. So most of the ground having a very high water table, so we need to grout. So it is a very costly exercise for us. And then we also have a ground movement because most of the development, the housing areas, there are some cut and fill area. And then some of the houses, they do renovation and then they don't do a proper structure. So most of the cracks is on the renovated components, like porch, back of house. So we have received many complaints. And then the other issue is on most of the area within the Kajang area or Cheras Kajang area, most of the road are traditional road. Most of the village, I would say 30% or 40% is a traditional village where the existing road is being upgraded. And then the existing utilities initially on the road table now is on the road premix, under the premix itself. So whenever we want to locate our shaft, we need to relocate the utility first before we can proceed and dig the shaft. And then the shaft also depends on the pipe size. If we have a small pipe size, the machine is smaller, so the shaft is smaller. But if you have a bigger pipe size, the biggest is 2.1 meter diameter, so we cannot escape from encroaching into the premix area. So we need to relocate the utilities before we construct the shaft. Another challenging is on the highway crossing. We have to make sure that there's no, the machine will not start in the middle of the highway. So we need to use a bigger pipes for the crossings. And then on the other note, the available of machine for the works, especially for rock machine, the number is limited. So we have to source for the machine, the correct and machine for the works. And then the spare parts also, because most of the machine are imported. So the spare parts also need to be imported, especially the fast-moving item to make sure that the work continue and we get the productivity that we want. Okay, these are the list of challenges that we have when we construct the pipings, the house cracks, complaints, the damage on roads. We have to deal with the public and then to quickly rectify all the damage so that the public is safe when they use the road. And then another constraint is the construction material, where when we order the pipe, we need to store the pipe somewhere along the road to avoid double handling. And then some of the community, or Taman is a gated community, so there's a lot of demand before we can come in and do the works. So in order to address all these complaints, we have set up a team to help the work to move. So this is a flowchart of the complaint coming in. So we will act on the complaint, and then we try to give the feedback to the public. If a small, we can resolve it. We attend to it immediately. Otherwise, it will take 2 hours. But for the traffic, we have a traffic team that will be mobilized and address the issue within 30 minutes to 2 hours. So in order to make the public understand on the works, we have a town hall to discuss with them what are the issues, what are they facing, what they are concerned about, and we try to address them. And from time to time, we do construction updates when the work will be completed. For the work progress, we have a website, we have a WhatsApp group to inform. We also conduct certain events, and we conduct a press release. Before we start work, we notify the public and put up enough sufficient signage before we start works. And then we also cater for complaint handling procedure, means that we put our hotline at our site for them to call if they have complaints. We also conduct some CSR program as and when we have something that we have to give to the community. These are the public engagement pictures that we have, exhibition that we involve for this project. And then we also conduct transport technology to the stakeholder. And then we also invite the public to visit our public information center that we have currently on site to share the knowledge for the project on the projects. The achievement that we achieved to date is we have achieved CIDB, SHASIC, which we comply to the best work procedures. 4-star in 2017, and then we got a 5-star in 2018. We also achieved a Best Minister KPI achievement in 2017. And we celebrate the 9 million man-hours without LTI. We also managed to get ISO 14001 on environment management. And then we have achieved longest microtunneling machine, 1,800 mm diameter pipe, curvature sewerage, which is showed earlier before we start the webinar, registered under Malaysia Board of Record. And then ongoing, we also participate in the Prime Minister Hibiscus Award. For this project, we provide hotline, email, website, Twitter, Facebook, Instagram, and PIC for the public to know more about the project. Thank you.
Major Zu, you finished?
Yes.
Okay, thank you very much for your presentation. So now we will have our panelists to review the questions that we have. So for our attendees, well, maybe we can just take maybe 2 or 3 minutes break. You can have your coffee or a washroom break. Our speakers will review the questions. Panelist members, you can click onto the question that you would like to answer. Just click answer live to the question that you want to answer. All our other attendees, this is the time for you to also pose your question. So if you have any question, please post now.
Hello. So this data showing the current performance of the treatment plant. We actually on slide 27, we already showed some indication on the performance of the plant. We can, the last column, the BOD is 96% removal. We achieved that. Suspended solid, we also achieved 93% removal. COD also achieved 88% removal. Ammonia 83%. Total nitrogen 80%, and oil and grease 96%. This is the actual performance that currently we are operating. Okay, is there any flooding issues that has troubled your site situation? If yes, how you handle it? Actually, we don't have any flooding issues due to our works. What we have is the shaft. Let's say the rain overnight. So when we start work the next morning, we have to pump up the water. And then the flooding issues due to our work is, I will say, almost nil. Ada. I hope that answered the question. How many percentage of the contract sum is for the sewer line? Oh, that one is I will say 75%, 70%, 70%. I would say. What is the lead time for complaint resolution, especially if it involves potholes or any road damage? Okay, we have emergency response team and task force. So the task force, if the our subcon don't take action within 2 hours, our task force will come in. but for temporary repair. So I will say the response will be 24 hours. I think I've answered this one. Is spacing of manholes 100 meters apart based on Japanese standards? Answer, okay, no. But it's being practiced. It's being practiced by the Japanese, but it's not the standard. Because you have, and it's related to the maintenance when we discuss in the workshop. So for smaller pipe, the breakage always happen. The pipe less than 300 mm diameter pipe. So they need a smaller distance so that they can service the pipe or cleaning the pipe. But for bigger pipe, bigger than 300 mm diameter, the blockage is unlikely to happen. So it can be, the distance can be longer. I hope that answered the question. Why there are two types of odor removal system proposed, used in a different area or both in the same area? So macam mana ni? What's the answer? Ayanzul will answer that.
Well, there are three different areas where the odor control systems are actually in place. One is the pumping station. The other one is the bioreactors, as well as the sludge treatment building. So there are three areas where the odor control systems are being placed. And I believe at all three stations are both in place. The biological removal as well as the carbon. Okay.
Any more questions not yet answered?
There is one question, Dennis. Can you still hear me?
I can hear you.
Okay. How much does BOD, SS, AMN been removed at primary sedimentation tank before it flows to the balancing tank? Now, as per the requirement, the BOD is removed, 30% is actually be removed at the primary set tank. The suspended solids are actually about 40% being removed at the primary set tank. And the total nitrogen level, we reckon about 10% of the total nitrogen level is removed at the primary set tank. I hope that answers the question.
Okay, Handy, can you submit the question from chat box to Q&A?
So the other one is have a prototype plant constructed to test the STP process before confirmation of design parameters. Okay, there's no prototype plant constructed to test the STP process, but Tokyo has done it for all the 13 plants in Tokyo using the similar process. So they have justified, they produce their calculation, they justify. And we go through a quite detailed workshop to confirm all these design parameters before we construct the plant.
If I may add, yes, that's correct. There is no prototype plant as per the choice of the deep aeration and step fit denitrification process. It has been successfully constructed in Japan, and there was a technical visit done by the team to visit numerous plants in Tokyo itself. And we are treating this plant as a pilot plant in itself, because there are some variants in terms of the design guidelines and so forth, and some of it actually basing on the Japanese guidelines, and we have employed that guidelines for this particular plant in our design. Thank you.
Any problem on public complaint about damage on the premises, like crack on wall, etc.? If so, how do you check if the complaint is valid? Okay, in our case, what we did is we make sure that we conduct a dilapidation survey before we come in to construct the shaft. That's number one. Number two, when they come and complain to us, we get preliminary inspection jointly together with our consultants and our experts to determine whether the damage caused by us or not. So during the construction, we also put up a instrumentation, a device to monitor the vertical movement and also the horizontal movement during the construction, to whether the crack can become bigger and bigger. And then if it's become bigger and bigger, we try to rectify it. We tell the house owner that we will rectify after we complete the job. We cannot do it immediately, because if we repair, then will occur during the construction. Until the construction stops, then that movement or whatever movement will stop. So how to check if the complaint is valid? That one is we hire expertise to determine. I hope that answered the question.
Okay, on the how efficient is the installation of the baffle plate. Now, we can't assess it based on the current plant that we are actually constructing. We are basing it, the efficiency, based on the data and the information produced by the Japanese based on the plants that they have actually constructed and operated on in Japan. So we felt that it's quite efficient. The transfer rate is quite reasonable. Slightly smaller on the transfer of oxygen rate that they have actually employed in this particular plant basing on the Japanese guideline. We hope that the plant is actually operating efficiently based on the adopted Japanese guideline on the oxygen transfer for the aerobic tanks. Okay, and I would like to answer the next question on the why choosing this particular Japanese treatment technology. Again, as what Major Zulkarnain has actually talked about during his presentation, there are basically two main components that need to be addressed. One is the high level of ammonia produced by the existing plants, which are not complying with the new Category 1 guidelines by the DOE. The other one is the deep aeration. Because of the land area, there is a constraint in the land area that was afforded to this particular project. Sorry? Can I continue?
Yes, please continue.
Okay.
I think there was some disturbance just now.
All right. So basically, by choosing this particular plant, we can actually address the two main issues. One is the high ammonia level. Basically, we can actually remove a high amount of ammonia before discharging into Sungai Langat. That will protect the downstream water intake, water treatment plant intake. And the other one is to basically to satisfy the requirement for 920,000 PE. We do need to have a deep aeration bioreactors that would actually reduce 50% of the footprint required. As per the comparison, if it's only 7.3 hectares, we can only treat 300,000 PE. While adopting this particular deep aeration process, we can actually treat to until 920,000 PE. So that is a remarkable kind of achievement using this particular treatment technology. I hope that answers the question. Thank you.
What is the current loading of the plant, I believe? So the current loading, at present, we have diverted 230,000 BE. So we open up 2 streams of the tanks for treatment. How is the performance of the STP to date? So far, we never fail to achieve standard A, category 1. So we meet the criteria, the design criteria. Notice that there is an introduction of baffle plate. How efficient is the installation of baffle plate? This they have done the R&D back in Japan. So the installation, the design was advised by them according to the practice. So we just follow. So I believe that it's not an issue as they have done all the R&D for that. I would say 100% efficient for this process. For the deep aeration, yes.
I would like to try to answer the question on the how do you make sure the anoxic part of the tank remains anoxic while the aerobic part remains aerobic if the water is being constantly saturated. Now, you can see the schematic of the bioreactors that was shown in the earlier slides. The step fit means that the flows from the clarified water is actually discharges into 50% of it into the anoxic tank 1 and anoxic tank 2. Okay, and we have the aerobic tanks 1 and 2 after the anoxic tank. They are actually in series. There are openings at the bottom whereby the flows from the anoxic tank 1 can actually goes into the aerobic tank 1, and from aerobic tank 1 it can go through the outlets in the bottom part of the tanks into anoxic tank 2 as well as to aerobic tank number 2 before it goes into the clarifier number 2. So at the top there are also openings which allows the MLS to flows from the aerobic tank 1 into anoxic tank 1. Okay, that would actually allow the food MLS to be constantly basically discharges into the aerobic tank 1 to be kept in terms of constant food for the bacteria or microorganisms. There are walls actually, there are partitions, wall partitions actually separated the anoxic tank 1 and aerobic tank 1. Okay, so there are four tanks in series altogether. Right, there are 16 trains, 8 trains in each bioreactor. There are 2 bioreactors, 8 trains in bioreactor 1 and 8 trains in bioreactor 2. And there are different of microorganisms playing its part in the aerobic tank 1, anaerobic tank 1, and aerobic tank 1. Oxygen is supplied into the aerobic tanks. And in the anaerobic tank, the microorganisms are actually starved of oxygen, whereas the process takes into consideration the carbon intake by the microorganism to break down the nitrates into nitrite oxygen. So that's where the process takes place. Different type of organisms actually placed in the different type of tanks and so on. Thank you. Okay, I'll try to answer these legal issues in terms of the Japanese guidelines. Well, I don't foresee there's any legal issues pertaining to this using the Japanese guideline. Of course, we have the MSIG. There are only guidelines. There are no laws or rules towards it. It's only a guideline for the MSIG. So there are some deviations that have been approved, allowed for this particular plan. And we have actually based on the guidelines that actually been employed by the Japanese consultants to design their plans in Japan. And more or less it's there in terms of guidelines. It's just that the sum of values actually varies a bit in terms of the hydraulic retention time and solids retention time and so forth. Okay. And all these deviations actually been put forward during a workshop between the turnkey contractor as well as the government officers and of course certification agency by WK. So the consultant put forward all the deviations from the guidelines and more or less they have actually agreed for us to adopt, presumably because we are actually constructing well, we can say as a pilot plan, employing the step fit process and deep aeration process. Okay, thank you.
Next question. Gentlemen, any more questions? Any more? Are you answering any more? Have we answered all the questions? I can still see 21 open questions, although I think some of them already have answered.
Okay, do you have many pipe jacking crossing highway? What's the minimum size of the pipe installed crossing highway? How you make sure all jacking successful without need to open a rescue pit? So the numbers of crossing highway, we have 6 numbers, 3 on Third Highway, the other 3 on Grand Saga. what we did is we select the pipe big enough so that we can service the cutter head, to change the cutter head if we drive through rock, especially. What we really worry is on the jacking, is on the rock issue. Other than that, we have no issue. So before we start the jacking, we do the SI. We make sure that the ground, there's no rock, then we can maintain the design pipe size. If not, we have to upsize where we can enter the pipe and service the cutter head. So for the smaller pipe, we don't have the door at the cutter head to service. But for the bigger pipe, we have. So normally the pipe size above 1,200 meter is the size for the pipe crossing highway. Is the effluent and sludge produced being recycled? We actually, some of the sludge are returned back to the primary to promote the bacteria growth, to assist the process of removing ammonia. For this tap water treatment plant, does the membrane treatment technology is implemented? No, we are not using any membrane technology. The discharge point is 300 meter from the outlet of STP. Is the distance as per DOE requirement? Okay, when we discharge to the existing main drain. This main drain lead to the river. It's not that we discharge it 300 meter from the discharge outlet to the river. Actually, within the plant itself, we have a main drain. So the main drain lead to the river. What do you do with the rest of the sludge? Unfortunately, we don't have space to process the sludge for other use. So at the moment, we take out to the landfill. This plant upgrading from SBR to CIS or construct new plant? Actually, it's a new plant. It's not an upgrading from SBR to CIS. The distance between
Major Zoo, we can't hear you. I think you have unmuted yourself.
What is the distance of the diffuser level and tank invert level? Any potential settlement in the tank? Okay, the distance of the diffuser level and tank invert level is 5 meters. So we put the diffuser at the middle. Any potential settlement in the tank? We have conduct the CFD to keep the settlement minimum. I hope that answer the question. How do you make sure the anoxic part of the tank remains anoxic? I think this one answered already. What do you do with the sewage sludge at the existing STP pump station, which have been decommissioned? Existing STP and sludge and pump station that where we decommissioned, we will send the sludge to the landfill. Okay. Any special requirement needed to maintain the baffle plate during the operation? The diffuser is attached to the baffle plate. Very seldom that we're going to maintain the baffle plate. But in case to maintain the tank or to clean up the tank after 5 years, we will do it as a major maintenance. But we can empty the tank and divert the flow to another tank. Is the diffuser attached to the baffle plate? Yes.
Oh, sorry, that question sorry.
Tengok web seminar. Web seminar.
Oh, okay.
Sorry.
Okay.
Two-step feed extended aeration also introduced at Pantai 1 STP. It is same with this plant. I will say similar but not the same lah. Because we are using a deep aeration for the process. Okay, slide shows 0.1 meter per second circulation velocity in aerobic chamber. Is this enough to avoid accumulation of MLSS, grid, etc.? Okay, we have done the CFD when we size up the tank, and so when we put the diffuser for this kinetic flow of the water within the tank, so it's very minimal, I will say. I hope that answered the question. How do you make sure the anoxic part of the tank remain anoxic? I think Engineer Zul already answered this question. What is the return activated sludge ratio been adopted or calculated? This one I need to see the mass balance. I need to see the mass balance punya diagram. I don't have the answer, the accurate answer at
It's
the moment.
okay. It's okay, Colonel. Major is okay. What
Yeah.
you can do is we can answer this via email to the participant.
Oh, okay. Say similar PE, how does this STP compare with the conventional STP in terms of capital and running costs as respectively, roughly please? I believe we have done in terms of selection of equipment, we use a VFD, variable frequency drive, for energy saving. We also make arrangement for the capacity of the equipment. Let's say pumps, under MSIG, most of the pumps are standard capacity. Kalau ada 6 pumps are on the same size. But in our arrangement configuration, we introduce 2 small pumps and 5 big pumps. So same goes with the blower. We introduce 2 small capacity blower and 5 big blowers. And in terms of a diffuser, we put it in the middle of the tank instead of the bottom of the tank. So at the moment, the running cost to maintain the plant is, I would say, better or at par with the current conventional plant. Can be lower, but it's subject to more study. I am yet to study this, but I foresee that it can be lower. I hope that answered the question. Okay, on the choosing of the technology, did you compare with this other available technologies available? I think the consultants have done this and then they have evaluated the technology, but on the comparison, thoroughly they have not done. But based on the available land size to fit in the process for 120,000 PE, I think this is the best technology available for compact STP. In fact, this is the most compact STP based on the land size. Okay, what is the expected solid accumulation below the diffuser grid? Okay, like I said earlier, we have done the CFD simulation for the tank. So the expected solid accumulation is very minimal. How do you make sure NOC part of the tank remains NOC? I think Engineer Zul already answered this question. What is the status progress of the decom work of the existing STP and or pump station. Okay, at the moment, the work is ongoing. We have taken over 13 numbers of plants from IWK for decommissioning works. For information, we have diverted the flow to the new STP, 230,000 PE, which involve about 60 or 70 plants. But the taking over of the plant from IWK is ongoing process. I think the question, how do you make sure the anaerobic part of the tank remains anaerobic while the aerobic part remains aerobic if the water is being constantly circulated? So there are a lot of research, R&D studies that the openings, they have some openings at the top and some openings at the bottom. So I think the details are already answered by Engineer Zul. I'm not sure whether you need further clarification on this.
Engineer Zhu, would you like to answer that question?
Well, I've already explained just now. The tanks are actually placed in series. There are 16 trains, 8 trains in 8 trains in bioreactor 1 and another 8 trains in bioreactor 2. So the bioreactors consist of the anaerobic tank 1, aerobic tank 1, anaerobic tank 2, and aerobic tank 2. They are in series. So basically, what it means is step fit nitrification is such that the flows are actually divided into equal flows, 50% each, being fed into aerobic tank 1 and anaerobic tank 1 and anaerobic tank 2. So anaerobic tank means that there are openings at the bottom which allows the flows from anaerobic tank 1 to go into the aerobic tank 1 and then goes into anaerobic tank 1, anaerobic tank 2, as well as aerobic tank 2. And there are also walls, partition walls. All these are actually 4 different types of tanks. And although it allows some flows in and out, but most of the flows are actually going into a series on one direction flow, which means from the aeration tank, the anaerobic tank 1 to aerobic tank 1. And then similarly, aerobic tank 2 and anaerobic tank 2 to aerobic tank 2 before being discharged into the secondary clarifiers. It allows some kind of return of the MLSS through the top openings at the top of the tanks to maintain the food for the microorganisms and bacteria. So that's where the MLSS comes in. But more or less, it doesn't allow basically the tanks almost remains anaerobic and the aerobic part remains aerobic. Okay, and only oxygen actually introduced in the aerobic tanks. It's not introduced into anaerobic tanks. The bacteria and microorganisms are actually starved of oxygen in the anaerobic tanks so that they can actually feed on the carbon to convert the nitrates into nitrite oxygen. That's where nitrification takes place. And for the aerobic tanks one, that's where the nitrification takes place in the presence of oxygen. It doesn't allow the anaerobic, the tanks always remains anaerobic, and similarly for the aerobic part as well. I hope that answers the question. Thank you.
From my screen, I can see 2 questions remaining. Not sure about you, gentlemen.
Okay, what is the design volume of methane gas and kVA power generator? So the volume of methane gas, the gas holding tank, 500 cubic meter. Sorry, 2,500 cubic meter. And then the power generated, we have 3 generators. The capacity is 600 kVA each. So total 1.2 MVA. So we have only one question. All answered. We have only one question. The return to the sludge, I think I need to refer to the mass balance diagram.
So for this question, we can answer by email.
Okay.
Would you like to answer by email?
Yeah, I will answer by email.
You want to answer now?
Yeah.
Okay. Okay. So that would be, then we will come to the end of our question and answer session. Many thanks to the Malaysian Water Association for hosting today's webinar. And special thanks to our speaker and panelists, Major Zulkarnain, Engineer Zulkifli, Engineer Dean Muhammad. Thank you for preparing for today's session and for answering all the questions from our attendees. We hope to have you back with us. So for all our attendees, well, right here on your screen, we just want to show one of the projects that we are currently busy with, and that is our Malaysia Technology COVID-19 Innovation Awards. So if you have innovations or initiatives that you have deployed during COVID-19, this is definitely a program that you would be keen to know more. So do visit us at our Malaysia Technology Expo Facebook page for more details. And next, we would like to announce, Henry, that would be our next one, yeah? So our next webinar is on coagulation-assisted ceramic membrane microfiltration for water and wastewater treatment, which will be presented by Dr. Eddie Wong from Kali Works Corporation, Berhad. And again, it will be held next Tuesday at 3 o'clock Malaysia time. So attendees, you can get more information from our Facebook page. Yeah, just look for Malaysia International Water Convention. And from this Facebook page, you will also get the link to watch today's webinar again on YouTube. So thank you, everyone, to all our speaker, panelists, attendees. We hope to see you again next week on Tuesday. Thank you so much and goodbye. Thank you. Thank you, Joseph. Thank you to all panelists. Thank you to all attendees, especially those who have joined us from Indonesia, from Philippines, and around the region. Thank you very much. Have a